is a country like the Philippines doing in space? So we call it, the title of presentation is Yamang Kalawakan. We invented this term. Literally it means space wealth or space riches. But figuratively, what it stands for is the collective resources of our country in terms of people, institutions, policies, the environment, the infrastructure that will allow us to seize opportunities in the burgeoning global economy, a global space economy. In other words, this is what we call this is the name we have given to our emerging space ecosystem here in the Philippines. Go to the next slide. Brief background. Maybe I should stand over here because I need to see this. PhilSA, by the way, it's PhilSA, not PSA, because PSA is the Philippine Statistics Authority. That's the Philippine Space Agency. We were established by law, Republic Act 11363, signed by the former President Duterte, August 8, 2019. So it's a 5-year-old agency. It's a central agency of government that addresses all national issues related to space science and technology and its applications, or SSTA. Contrary to what many people would think, that space agency is under the Department of Science and Technology, it is not. It's under the office of the President. And there is a Philippine Space Council, which I'll talk about in the next slide. Now, the President is keenly aware, President Marcos Jr. is keenly aware of the space program. In fact, in the United Nations General Assembly, September 2022, he had the following message, and I read it in part. I quote, "The Philippines is preparing for the future by laying the governance framework that will allow us to pursue digital solutions towards a more modern economy and expand our presence in outer space." He went on to add, "We need to start by defining the norms of responsible behavior in cyberspace and outer space." Now, you look at the space program in the Philippines, there is a Philippine space policy that kind of covers the activities of the space agency. And there are 6 key development areas. I enumerate them here: national security and development, hazard management and climate studies, space industry capacity building, space R&D, space education and awareness, international cooperation. So you can see from the gamut of these, the collection of these areas, that in a country like the Philippines, there is a lot of heavy lifting to be done by a space program. That is why it's placed under the office of the President, so that it can coordinate activities and make our investments in space trickle down to different departments and their mandates for maximum utilization and feedback. Okay, let's go to the next slide. There is a Philippine Space Council. This is a high-level council that is chaired by the President. You see there on the table on the left, the composition of this council. There are 2 vice chairs. The first vice chair is the Secretary of National Defense, and the other vice chair is the Secretary of Science and Technology. The other members of this council include the Secretary of Finance, Foreign Affairs, DTI, DICT, who else did I miss? NEDA, I mentioned DICT, and the chair of the Senate and House Committee on Science and Technology. So the PhilSA DG is the head secretariat. This council has met 8 times already over the past 5 years. And in the 6th and 8th meetings for this council, President Marcos himself chaired it. And he visited the facilities, the office, and had a tour of the different exhibits there. Okay, next slide. What comes to mind when we think of the space program? Probably think of astronauts, rockets, astronomy, space exploration. That's well and good. That's true. That's valid, because we're all curious about the origins of the universe. But then, there's very practical applications of space. When we open our mobile phone and we try to order food on an app, or we try to order transportation to bring us from point A to point B, the mere act of invoking that app already calls on at least 4 different space technologies. Number 1, the map on our phone is generated by satellites taking pictures of the Earth, and these are rendered into maps. Number 2, our position on the map that we see are calculated by satellites orbiting overhead. These are GNSS, Global Navigation Satellite Systems, which calculate our position on the map. And I know Dado is a pioneer of this, because he had was chairman of SURF at some point, one of the Intel of GPS chips. And the third thing is that the data that we send on our phone goes to the internet. Part of the internet travels to space, especially in hard-to-reach areas through satellites. Number 4, what's the other space technology that affects our daily lives? The weather. Satellites measure the weather. And these weather reports get to our phones, and they somehow influence the route that is calculated for us to go from point A to point B. So this is invisible infrastructure that is happening, that is in the background. Imagine if all these satellites were switched off for 1 day, or 1 hour, or maybe even 1 minute. It is not just the global economy that will be disrupted, it is our very way of life that will be disrupted. Okay, so much that, well, this global space economy is worth about $500 billion at the moment, according to some reports. It's growing at a CAGR of 8 to 9%, and then they say it will reach $1 trillion economy by 2035, according to some reports. Now, this global space economy is divided into 2 components. Number 1, the upstream. Number 2, the downstream. What is the upstream? Literally up there. So everything that goes up there, the satellites, everything that brings them up there, the rockets and the spaceports, everything that keeps them up there, the ground stations, the antennas, the command and control systems, that's the upstream. Now, when we put things up there, obviously we use them for some purpose. That's the downstream. The downstream, you use satellites for Earth observation, use satellites for the internet, use it for telecommunications, positioning, navigation, timing. That accounts for a majority of the global space economy, about $400 billion. The upstream is a small fraction of it, but it is growing faster than the downstream. There are now 9,000 satellites in low Earth orbit. More than half of that is owned by one company. And you probably know, he gets mentioned a lot, so we'll not mention him here. So that is increasing. There is now a full-fledged economy 400 kilometers above the Earth, or between 400 to 1,000 kilometers. Next slide. And so your space agency has therefore formulated this vision and mission. Our vision is that of a Filipino nation that is bridged, uplifted, and empowered through the peaceful uses of outer space. And our mission is that we dedicate ourselves to promote and sustain a robust Philippine space ecosystem that adds and creates value in space mula sa Pilipino, para sa mundo. Next. Now, when we talk about the space program, we still get a lot of questions. Why do we even have a space agency? The first thing, I guess the simplest way to answer that question is to remind ourselves as a country what we are and maybe even where we are. Look at the map. What we are. What are we? We are an archipelago. We have Filipinos living on different islands separated by sea. There must be a way to better bridge these islands and connect Filipinos to each other. How about where we are? We're in the Pacific Ring of Fire, where there's a typhoon belt. So we deal with a lot of these natural calamities and also with climate change. And so to pick all of that, when we describe the space program, we look at a so-called value chain. Let's click on the value chain. What is a chain? You have these components, and their presence and their interaction will lead to socioeconomic value and benefit at the end of the chain. So the National Space Program, ladies and gentlemen, is about this value chain. It's about making investments in the upstream, right? The question we ask ourselves is, do you have them, yes or no? Number 1, satellites. Do you have satellites? We have 1.2 sovereign satellites right now. I'll show you a picture later. Now, when you say you have access to satellites, the second thing that you ask yourself is, are these satellites, or maybe not, maybe you rely on other countries' satellites. The next thing you ask yourself is the data or services from the satellite, are they accessible to you? Or are they even suitable for you? Because other countries solve their own problems with space technology. So that's the second part. Now, assuming that these satellites, you have them, you have access to them, they're suitable for you. The next question is, can you bring their services down towards Earth? Do you have infrastructure on the ground to host the data, to download the data? And then once the data is on the ground, do you have capacity to analyze that data and create value out of the data? And once you say, okay, yes, I do, we can add value to that data, we can process that data. The next question, the next thing is the value of that. Is there impetus and resources to act on those insights that you generate? In other words, are there users, right? Because if there are there's nobody using whatever it is that you produce, then there's probably very little socioeconomic value and benefit that you can derive. That separates an invention from an innovation is the fact that an invention is something that is used, right? Okay, so that is the framework, strategic framework for the National Space Program. Let me click on that and let me focus first on the upstream and I'll speed through the downstream. Because you're all electronics and semiconductor people here, let's go to the next slide. Through the support of the Department of Science and Technology, even before PhilSA was born, we have been producing these satellites. The first one, 2016, Diwata-1. What you see there is not an animation, it's actually pictures of our satellite being deployed, pushed out of the International Station from the Japanese Kibo module, and then in its first moments in orbit. That's Diwata-1. It carried four cameras. It was followed by, so Diwata-1 is about the size of a balikbayan box, 50 kilograms. It was followed by a CubeSat. CubeSat, well, can I touch it? I'll touch it. It's very careful against electrostatic discharge. That is a CubeSat. It's about 1 kilo. That's Maya 1, Maya 2. Now, we sent Filipino students to Japanese universities to build this in the beginning. And after that, they came back. And now we're building these CubeSats in a local university. So since Maya 3, 4, 5, 6, they've all been produced from the University of the Philippines by graduate students building these things. And in Maya 7, which is now, this is called the 1U. Maya 7 is a 2U, so 2 CubeSats this size, is being built by a consortium of universities, UP, LaSalle, University of San Carlos, I think MSU, IIT is there as well, and a couple of others. So that's Maya 7. They're all working on that now. Now, as we build these satellites, you see in those notes, we try to increase the local content. So if Diwata 3 will be launched eventually, it will carry 9 locally developed components to be tested in space. And the next project we have, or it's ongoing, is the MULA satellite, the Multispectral Unit for Land Assessment. This is a bigger satellite, 130 kilograms. And the important thing with the satellite is that we're not buying it, we're building it. We have 16 engineers in the UK building it together with the British engineers. And at the end of that, we get a license to remanufacture the satellite in the Philippines. So the next time we build it, we'll try to build it here and try to engage local companies to put components into the supply chain of this satellite. But eventually, we will not be just the customer. It's not just a space agency, it's a customer. Turn around, face the global market, and be part of the global supply chain for these space-qualified semiconductors, electronics, machining, etc. Okay, I think next, this is our roadmap for these satellites. You see, when we build on that yellow ear there, the MULA class satellites, once we build the first one, we gain a license to remanufacture it in country. We will explore different payloads, different cameras, even a synthetic aperture radar payload in that satellite, and increasingly engage local companies to be in the supply chain. So why do companies abroad, in a way, open up their blueprint of the satellite for Filipinos to learn about? Now, because they themselves, they're interested in diversifying their global supply chain. If a Filipino company is able to do something better than their current supplier, then why not choose that Filipino company to be part of your bill of materials for your satellite? So that is the approach here. And I think we have a good chance. No? So let's go to the next slide. Let's play this video.
When the Philippines began building satellites, we started small. As small as a suitcase. Yet the stakes were high and the challenges were great. After the success with 6 of these small satellites, the Philippines is ready for something bigger. In December 2020, the Philippines kicked off the Multispectral Unit for Land Assessment, or MULA satellite project. Weighing around 130 kilograms, MULA will carry a true color camera that can capture higher resolution images, covering around 73,000 square kilometers of our country in one day. Data from MULA satellite will be used for addressing food security, disaster resilience, environment conservation, and protecting our national sovereignty. The Department of Science and Technology jump-started the funding of MULA. The project was jointly implemented by the DOST, Advanced Science and Technology Institute, and the University of the Philippines, Diliman, in coordination with the Philippine Space Agency, or PhilSA. 16 Filipino engineers who underwent a know-how training and transfer program in the UK are involved in building the satellite and are now part of PhilSA. The training capacitated our homegrown engineers, not just with knowledge, but the license to build more local commercial satellites in the future, leading the way for the creation of a robust and thriving space industry to support the country's space program. PhilSA will oversee the completion and launch of MULA and manage its operations. MULA in Ilocano means plant, pointing to the satellite's mission on food security. In Tagalog, it means point of origin or beginning, which symbolically signals the Philippines' foray into a new era in satellite development toward the vision of a nation bridged, uplifted, and empowered through the peaceful uses of outer space.
Let's go to the next slide. It's actually happening now. Next. So what's so special about these satellites? Because space is harsh. You have radiation in space. You have solar panels possibly arcing because of the plasma environment, causing short circuits and damaging the solar panels. You have temperature fluctuations. When we are here on Earth, when we feel hot, what do? You pull out a piece of paper or a fan and we fan ourselves. That's because there's air. But in space, in the absence of air, how do you distribute heat? How do you dissipate heat? Otherwise, things get malfunction. And of course, you have to deal with space heat. Go to the next slide. Cover your ears a little bit. Let's pause that now. Now, what does